Supplemental math videos from Circle Christian School. Many of our shapes have parallel lines already in them, and when they do, the 6 rules apply also. That you have 4 rules of congruency along a transversal, and the 2 rules where the angles are supplementary and equal 180 degrees. The deal here is to make sure you identify the parallel lines and the transversal that goes through them. All right, here we have a shape that has parallel lines inside as a part of it and several different transversals. So the first thing that we're going to do is, of course, identify our parallel lines. And I'm going to tell you that one of the best things to do is just extend them past the shape. And that way it looks a little more like what you had been doing. Lost my red. There we go. And then identify things like the transversal. Well, the first one I'm going to identify is this one going right down the middle here. And again, extending them kind of help with what's going on here. And so I've got my shape. And I'll notice, and so first thing we got to do, generally you want to go find X first, then go find the Y. So I'm going to take a look at these two right here and so on. First off, I see that they're on the inside of the parallel lines, but they're jumping the transversal, doing that little jaywalking thing, which qualifies them to be alternating interior angles. And the rule for alternating interior angles is that they are congruent to each other. So my setup, or your setup, is going to be 4x equals the 52. That's the property that happens with these cool angles. And we divide both sides by 4, and we see that x equals 13. Okay. So we have the x, and x equals 13. And if we test it back inside here, 4 times the 13 is 52, and we go great. Nice double check, because these two are congruent. But now we have to go find y, and y is going to present a unique problem inside here, because although we have this transversal going right down the middle here, and we have these nice 2 little parallel lines, the angle that they're referring to over here, this angle right inside here, is not exactly the whole angle that's right here. It's a part of the angle. And that's where the box down here is going to become a very important part of the shape here. Now, remembering that this is 90 degrees, which means that this is 90 degrees over here. That's definition of perpendicular lines and congruency of right angles. That up here is also going to be 90 degrees on the other side, which means these two together, this is kind of, gotta follow along here, these two together are going to equal 90 degrees. So, knowing that part of it is 52, that means the rest of this, and let me kind of get rid of a little bit of busyness inside here, that the rest of this angle inside here is the difference of 90 degrees, take away the 52. So 90, take away the 52, the little difference inside there, is actually going to give us 38. So we know that the angle with the blue arrow here referring to inside here is part of that 90 degrees there, that we have 3y plus the 2 is going to equal the difference of our 90-degree angle here. Oh, lost my blue again. There we go. So it's actually going to equal the 38 degrees. So you got to be a little bit careful here and know a little bit about shapes and right angles and a couple other things. So minus the 2 and minus the 2. That's going to give us a 36 equals the 3y. And great minds go 3 times what is 36? And it's 12. And so x equals 13 and y equals 12. All right, have an awesome parallel and perpendicular day.